This is Algebra 2. This is the first lesson in Unit 1. There are 5 lessons in this unit, so they're pretty fast-paced. But the first one starts off with interval notation. And it's a review of interval notation and the concepts related to it in terms of function notation, infinity, and domain, endpoints, range. A lot of different things like that, those concepts. So we're just going to get started. So first of all, when you see a number line, let's create a number line here. You see a number line, has numbers on it, has 3, -3, -2, -1, 0. The interval on this number line is between two numbers. It's the segment between two numbers. So an interval describes the beginning and end of points on a line. We use interval notation. In this case, we're describing the interval with the endpoints. So it's a shorthand or abbreviated way of the segment and all the points between. It's a shorthand way of describing the segment and all the points between. So for this particular segment between -2 and -1, I would describe it as hard bracket, -2, -1. But how do you know whether or not to use parentheses or hard brackets? Well, first, let's look at this. Let's examine what endpoints are when we're given an interval in interval notation. So here I have 3, I have endpoint of 3 and an endpoint of 8. Easy peasy stuff. Now look at the next one. What's your endpoint? I have only one endpoint, 2. For negative infinity, there is no endpoint because the segment moves forever to the left. Looks like this. Just goes there forever. It's going towards negative infinity. Okay? Now, what about these brackets? What's the meaning of these brackets? Well, when you have the hard brackets, so this bracket, it's left-hand bracket or the right-hand bracket, it means that the number that it's next to is included. And we fill in a circle at the number on a number line. Okay? So when the bracket is on the left, a left-hand bracket, right? The bracket means that the number is less than or equal to all other numbers on the interval. So if I'm not even going to put numbers here. Just going to put in a big hole here. So this number right here, we'll call it, actually we'll put a number there. We'll call it 2. This number, when I notate that this number is included in this segment, let me make that blue. It's included in this segment. I'm going to say close bracket 2. 2 is included in the segment. Okay? Now, what about this number over here? Let's say it's 8. Well, if I want to make sure that 8 is included, I'm going to do close bracket right there. So to finish this sentence here, on the right, the hard bracket, this is the hard bracket, means that the number is greater than or equal to all numbers on that segment. So look at 8. 8 is greater than or equal to all numbers between 2 and 8. 2 is less than or equal to all numbers between 2 and 8. The or means that the parentheses is next to is excluded. We exclude these numbers. So the or statement, or graph, if we had or graph, same numbers. Here's 2, here's 8. We wouldn't fill in those holes. It would be a circle at 2, circle at 8. And in fact, we would use parentheses to note that 2 is not included in the segment. It just means that 2 is less than all the numbers between 2 and 8. And 8 is greater than all the numbers between 2 and 8. Okay? Now, for infinity, negative infinity, we just kind of briefly went over this. But negative infinity, or symbolically, negative halfway figure eights, means the line extends forever towards the left, or down, or down, or down. Make a little note, or down, depending on whether we use the x-axis or the y-axis. So for example, if I were going from -2 on a number line, let's say I have a number line, -1's on the other side, and I was going all the way to forever. I would put an arrow at the end to notate this is forever, and put a bubble here. So my interval looks like this: negative infinity to -2 to negative infinity. And I would notate it by a heavy line going towards infinity. So -2 is greater than all of these other numbers. On the other hand, if I'm going towards positive infinity, my number line is going to the right. It's going to the right. Let's say it starts at -1, right? And my hole is filled in here. So I'm going to use a hard bracket for -1. But it's going greater than, so it's going positive infinity, right? And I notate that with the sideways figure 8, but it looks like this. Heavy bracket, heavy segment here, heavy line segment to show that it's going to positive infinity. Now, we're going to practice an example on a number line. So I'm going to find 3, and I'm going to find 8. I'm going to make 2 holes, one at 3, one at 8. Okay? Now, 3, I know that this segment is filled in between 3 and 8. But I don't know yet, is 3 included? So do I fill in 3? Is 3 equal to some of those numbers? Yes. I fill it in. What about 8? Do I fill in 8? No. So my segment just looks, just briefly, just an overview, looks like that. So 3 is less than all those numbers, less than or equal to all those numbers, and 8 is greater than all of those numbers in between, all of those x values in between. Okay? Look at the next one. We have it's going to negative infinity, so it's definitely going this way, right? But the other endpoint is 2. I'm going to find 2. Now let's see if it's included. Nope. This point is excluded, so I don't have to fill it in, and I can just make a heavy line segment. This is a ray, actually, going to the left. And here's all my x values. This 2 is greater than all of those numbers. It's greater than all of those numbers. Okay? That's how you graph a number line using interval notation. Now, I kind of briefly just kind of threw set notation in without really talking about what I was doing just now. But set notation is just another way of describing an interval. The difference is we don't use brackets. We're using the less than, greater than, equal to, all that, those symbols. Okay? And the set typically is enclosed in curly brackets. I should probably write that out. Let's see, curly brackets. Symbolically, looks like this. Okay? And it describes the set. So there's going to give you these intervals, these segments, in interval notation. You're going to write them in set notation using what you know. So 3 is included, so it's equal to the interval, some of the numbers on the interval. And 3 is less than because it's on the left. 6 is greater than all numbers. So this is how I set it up. I figure out what my number on the left is doing, what my number on the right is doing. That means, is it equal to on the left? Is it equal to on the right? On the left it is. So that means 3 is less than or equal to x, and x is less than 6. So set notation says I create my curly brackets, and I'm talking about x values, so x bar, and then 3 less than or equal to x less than 6. Curly bracket closes. On the next one, we're still talking about x values. So I know for sure I have curly bracket, x bar as a part of my answer, and curly bracket over here. Right? Now, for negative infinity, I'm just like when you have a positive infinity or a negative infinity, you're just going to use x. And you're just going to use the number on the left-hand side to make a statement. Well, x is less than 2. It's not equal to because this is a parentheses. So x is less than 2. And you're done. Okay? Another example, let's say we have negative 2 and 7. Then I have negative 2. It's not equal to, so it's less than x. And then 7 has a hard bracket, so it's also equal to. So in a set notation says curly bracket x bar negative 2 less than x less than or equal to 7. Close curly bracket. One more example. Let's say we have hard bracket 7 to infinity. Remember what I said about these are special. Put the x on the side of the infinity, bring your number down, and this is a hard square bracket, so it's equal to. 7 is less than. So set notation says x bar 7 is less than or equal to x. Close the curly bracket. Now, if I wanted to do these numbers on a number line, with just a little bit of practice here, from negative 2 to hard bracket 7, so negative 2 have a excluded hole, so it's not filled in, and then to 7, it's filled in, and I make my graph, my number line. For the next one, it was 7, hard bracket, and to infinity, closed parentheses. So at 7, I fill in the hole, and then just make a line going to the right. Okay? Now, the U. The union in interval notation, it's also called a U. Okay? It joins intervals when there's a break between and there is a need to describe a set of intervals in shorthand. So basically, look at the next problem. It says the union of 3 8s. So let's create a number line here. Let's create a number line. Here's 1, here's 2, here's 3, 4, 5, 6, 7, 8. So I'm going to use the color blue to describe this union. So from 3 to 8, from 3, and it's filled in. So from 3, a segment from 3 all the way over to 8. Okay? Now, on a graph, graphically, it looks like this. Okay? So from 2, and we're going towards negative infinity. Okay? Algebraically, the union can be described this way. Hard bracket 3, 8. Union, don't put a U like I did, straight up U. Negative infinity, 2. So we're going to redraw this down here so it sinks in for you. So from 2 to infinity, that's the first part. And then from 3 to 8. Okay? So don't overlap like I did. If you do, erase it. All right? Now, you're going to work on describing the graphs in one dimension, in interval and set notation. And you can pause the video to work on that. And then I'm going to move on to interval notation and set notation in 2 dimensions. Okay? So, interval notation and set notation in 2 dimensions. So previously we wrote interval notation and set notation in only 1 dimension. Graphs typically have 2 dimensions. Left to right. And up and down. 2 dimensions. Means directions. The domain consists of all the x values that points touch. The range, oh sorry, not the range. So the domain or x values extend from left to right. An example of the domain, we could say x equals 4, or we could say f of 4. The number inside is an x value. Okay? Now we're going to practice writing the domain of the objects below. When I have a discontinuous graph, this is a discontinuous graph. That means the points aren't connected. I'm just going to look at my domain here. And the interval, since these numbers aren't connected, I'm just going to write individual numbers. So for my interval, I'm just going to say -2, -1, 1, and 2. If you can't see it, circle where you see those blue dots on the x-axis. Okay? Now if I was doing set notation, I would write curly bracket, x bar, -2, -1, 1, 2, to show that these points are not connected. On the other hand, if I am looking at the next one, it's a straight line. This is different. So it's kind of hard to see what these x values are doing. But if you look closely, these x values keep getting more and more negative as you go to the left. So let's start here. Let's start here at 2. At 2, and then at 1, at 0, when x equals 0, there's a point there. When x equals 1, point there. When x equals 2, there's a point there. When x equals -1, there's a point there, and it keeps going. The x values keep getting more and more negative. So my interval, I'm going towards negative infinity on the left. On the right, my x values keep getting bigger and bigger. If I keep going at 3, keep going, it reaches 4, and I can keep going more and more, and I'm going to positive infinity. If you can't see it at this point, we'll keep working on it, and you will. Now, set notation, the way we indicate set notation that this x values touch all real numbers is we actually write x, curly bracket x, x belongs to the reals, or x is all real numbers. Okay? Parabolas have the same thing going on. All right? As I can get, if I go towards the left, the numbers get smaller and smaller, and they're going to infinity. So here's 3, have a point at 3. Here's 2, have a point at 2. Here's 1, have a point at 1, have a point at 0, -1, -2, -3, so on and so forth. I'm going from negative infinity to positive infinity. Then again, we have x bar. X belongs to the set of all real numbers. They're all real numbers. Now the range consists of all y values that a point touches. The range, or y values, extend going up and going down. So my range for this part, the example is y equals 3, or we could say f of x is another way of saying y. It also equals 3. So we're looking at the range. That means we're looking up and down. We're not looking side to side. So here I have points at 4, 2 points at 1, and 1 point at 0. So my range is 4, 1, 0. If I'm doing set notation, a little bit different this time. We're talking about y values. So curly bracket, y bar, 4, 1, 0, close bracket. Now, what about this straight line? Well, let's look at the y values. I have a point at 4, and it's going to keep going, so I'm going to positive infinity. I have a point at 3, have a point at 2, 1, 0 right here, at -1, at a point at -2, a point at -3, and it keeps going forever and ever until I go to negative infinity. So my range is negative infinity to positive infinity. If I want to talk about what the range is in terms of set notation, it's going to be curly bracket y bar. Y belongs to all real numbers. Now, what about the y values for this parabola? Well, if I look, my y values start at 0. They start at 0. They keep going at 1, 2, 3, 4, 5, 6 points at 7, and 8, and 9, and so on and so forth. We keep going up forever and ever towards positive infinity. So my range for a parabola, I have a minimum. And it's square bracket, 0 to positive infinity. If I want to write this set notation, remember I said 0 less than or equal to x. So set notation would say curly bracket x bar. Oh, sorry, not x values. Remember, we're talking about the range. Curly bracket y bar, 0 is less than or equal to y. Okay? Moving on, I want you to go ahead, write the domain and range using interval notation on the next page. You can get more practice if you'd like, and just check in with me before you leave. Complete the classwork, and your homework is in your homework packet tonight. Have a good day. That's the end of lesson 1.